Hi, welcome to my video on derivative product rule, and this is a review of the derivative product rule. And as in all my reviews, this one is going to be marked out of 29, so you give yourself a score for each question, total up the page, do that for each of the pages, and when you're finished, put the score over 29 and divide 29 into the numerator, get a decimal, move it 2 places to the right to get a percent. Here we go. Number 1, using f of x times g of x, state the derivative product rule. Well, this is f of, so the derivative product rule is that we have a product of f and g, so the derivative of f times g is the derivative of f times the g of x, add on f of x times the derivative of the g of x. So it's really, if you think about it, it's f times g derivative. It's the derivative of f times g plus f times derivative of g. And that's the way I do it. I do it this way in division 2, and I always do the derivative of f first. Number 2, so if you have that down, give yourself a mark. Find d dx of 2x minus 1 and 5x plus 3 using the product rule. Well, if you call this one f and g, so the derivative is 2x minus 1 derivative times 5x plus 3, add on 2x minus 1 times 5x plus 3 derivative. So there's f and g, derivative of f times g, and add on f times the derivative of g. So the derivative here, this derivative of 2x minus 1 is 2 times 5x plus 3. And we have 2x minus 1, and the derivative of 5x plus 3 is 5. Derivative of 5x is 5, derivative of 3 is 0. And we do the multiplication first, so that's 10x plus 6, add on, 5 times 2x is 10x, 5 times negative 1 is negative 5, add that up, and you get a 20x plus 1. So if you did the derivative correctly, you get a mark. If you did the final answer, give yourself a mark, 2 marks altogether. And number 3, find the derivative. We got 2 dots there, but that's nothing, we just ignore that dot. Find the derivative of each. So again, we have a product, 2 different functions. We have x cubed and ln x. They're 2 different functions, so that's f and g. So it's the derivative is f cubed derivative times ln x plus x cubed times ln x derivative. So that's f prime times g, add on f times g prime. Derivative of x cubed is 3x squared ln x. And we have x cubed. Derivative of ln x is 1 over x. So that's 3x squared ln x. And x cancels into x cubed to give you x squared. So if you have this correct, and if you simplify it here, you get 2 more marks. And again, we have the e of x and sine x. So this is f and this is g. So it's the e of x derivative times the sine of x, add on e of x times the derivative of the sine of x. E of x derivative is e of x sine x, and we have e of x. Derivative of sine x is cos x, and we can't simplify that. We can factor if you wish, but you don't have to. So the e of x is common, so we get sine x plus cos x. Just that we just want to write it different. Again, if you did the derivative, and if you factor that out or you didn't, you get 2 marks. C, we have, again, 2 different functions. We have x squared, we call that f, and 7 to the x, which is exponential, is the g. So we got the derivative of x squared times 7x plus x squared times 7 to the x derivative. So that's f and g. That's f and g. Derivative of f times g plus f times the derivative of g. So x derivative of x squared is 2x to the 1 times 7 to the x. And we got x squared, and the derivative of 7 to the x is 7 to the x ln 7. And if you want to simplify that, you can. You can, if you wish, but I see a x is common, and I see a 7 to the x. So if I take that out, I get 2 right there, plus I get an x here, ln x. Again, if you have that answer, you give yourself 2 marks. Total for that page is 9. Hopefully everything's going well. You know how to do the different derivatives of the functions, and you know how to do the product rule. Number 4, the p of x equals x to the 4th plus 2x cubed times x squared plus 4x plus 7. Find the p prime of negative 1. P prime is the derivative, so p prime is the derivative. And let's say this is a product of two different. I could multiply this out by FOIL and then do the derivative without the product rule. But if you do the derivative here without multiplying it out, so the derivative of f is x to the 4th plus 2x cubed. That's the derivative of f times the g is x squared minus 4x plus 7. Add on, and it's f, which is x to the 4th plus 2x cubed, and it's x squared minus 4x plus 7 derivative. And we take our time. Derivative of this polynomial is 4x cubed plus 6x squared times x squared minus 4x plus 7. And we have x to the 4th plus 2x cubed. And the derivative of this trinomial is x squared is a 2x, negative 4x is negative 4, derivative of 7 is 0. Now I could multiply all that out and expand it, but I'm only doing the p prime of negative 1. So the p prime of negative 1 means that I can put a negative 1 in each of these polynomials and simplify each bracket like this. So let's put a negative 1 in here. I could, again, multiply all this out, and multiply this out and add them up, and then put a negative 1 in, but it's easier if I put a negative 1 here now and simplify each bracket first. That makes it easier. There was an example of that when we did our unit plus 7, and we got a negative 1 to the 4th plus 2 negative 1 cubed, and we have 2 negative 1. So we have to simplify each of the brackets first. Because we do PEMDAS, we always do inside of the brackets first. Here we go. Negative 1 cubed is negative 1, so that's negative 4. Negative 1 squared is 1, so that's 6 times 1 is 6. Negative 1 squared is 1. And we have negative 4 times negative 1 is 4 plus 7. And right here we have negative 1 to the 4th power, which is 1. Negative 1 cubed is negative 1 times 2 is negative 2. Negative 2 times negative 1 is negative 2 minus 4. So each bracket we're going to simplify. That's a 2. And that's a 12. Okay. All right. We got a 12 there. And let's just looking around. Negative 1. And that's negative 6. So that's multiply first, PEMDAS, plus 6. So that makes that a 30. So just checking with the negative 1. That's 1, that's a 4, and that's a 7. So 1, 4, and 7. Perfect. 30. And there's 3 marks here. So if you did the derivative correctly, right here, you get a mark. If you subbed in the negative 1 here and got this, and you simplified it to 30, 3 marks altogether. Number 5, find the equation of the tangent to k of x at x equals 4 if the k of x equals the root of x times 5x plus 12. So this is two different functions. So this is f and g. So to get the equation of the tangent, you got to do the derivative. The derivative is the slope of the tangent. So to get the equation of a tangent, I need a slope and a point. So let's do the derivative first and get the slope. So k prime is the derivative. So we got the derivative of root x is 1 over 2 root x that we practiced before, times the g, which is negative 5x plus 12, and it's derivative of f times g. Now it's f times the derivative of g. So we get the derivative of g, which is negative 5. So we could simplify that, but we want it at x equals 4. So the derivative of x equals 4, so we put a 4 in the place of x. We take our time and put a 4 in the place of x. And so we have a 4 in. Now we simplify it. So square root of 4 is 2. 2 times 1 is 4, so that's 1/4. Negative 5 times 4 is negative 20 plus 12. So, and we have square root of 4 is 2. And that gives us 1/4. And negative 20 plus 12 is negative 8. I did it inside the brackets first. So that gives us a negative 2 minus 10. That gives us a negative 12. So the derivative is the slope of the tangent. So the derivative, slope of the tangent is negative 12. So what we have now, we want to find out the point that occurs. So the k of 4, it occurs at 4. So I'm putting a 4 in this expression here. So we got the root of 4, negative 5 times 4 plus 12. So the root of 4 is 2. That's a negative 20 plus 12. That's 2 times negative 8. So the point, that's the k of 4 is 16. So that's the point 4 comma 16. So the equation of the tangent is y equals mx plus b, slope y-intercept 4. So we have the slope is negative 12. This is x and y, so y is 16 and x is 4. So that's 16 equals negative 48. I almost see that there. I just looked. No, that's negative 16. That's negative 16. So those little errors I got to be careful with. So this negative 16 plus 48 equals b. So b is 32. So y equals mx plus b. Y equals, slope is negative 12. And b is 32. So to get the equation of the tangent, I need to get the derivative, plug the value of x in to get the slope, and then plug that value of x into the expression, or into the equation, to get the point, and plug the point in to the line to get the equation like I did here. And there's 8 marks, 5 marks for this question. So if you did the derivative correctly, you get a mark. If you got a negative 12, you get a mark. If you have your point, you got a mark. If you got the 32, you got a mark. If you got the equation, 5 marks altogether, so that's 8 for that page. And we have one more page to do, and it's to find d dx of each. So this is a product, so this is f and g. So this is x squared derivative times y plus x squared times the derivative of y. So the derivative of x squared is 2x times y, x squared. And when you do the derivative of y, you do the derivative as if this was an x. So this is an x, we would get a 1. But when you do the derivative in terms of y, we will always get a y prime. We practiced that in an earlier video. So we do the derivative of y the same as if it was an x, and then we get a y prime. We practiced that earlier. Just check it out. And so if you have this y prime, you have this done, give yourself 2 marks. Now we have b. Notice we got y squared ln x plus x cubed. So this is a product, and this is an addition. So if you call this f and g, this is a separate one. So this is y squared, that's f, derivative of f times g plus f times derivative of g, and derivative here, this is x cubed derivative. Here we are. So here's the product rule. Now we're doing the derivative of y in terms of x. So the derivative of y squared is 2y. But because we do the derivative of y in terms of x, we get a y prime. Ln x, we get y squared. Ln x, derivative of ln x is 1 over x. And derivative of x cubed is 3x squared. Simplify that, and we have 2y, y prime ln x, and we have y squared over x, and we have 3x squared. And we have 3 marks, so if you did the derivative of this product correctly, you get 2 marks. If you did the derivative here, you get a mark, and there's the final one, 3 altogether. Now, notice we have the e of x, 3 to the x, and sine x. That's 3 different functions, f, g, and h. And when I did this in a video, the derivative here, the derivative of this is derivative of f times g times h plus f, derivative of g times h plus f, g, derivative of h. So you write down each one, f, g, h, f, g, h. So you do the derivative of f here, derivative of g here, derivative of h here. That's if you remember the shortcut. So here we go. So this is f, so we do the derivative here. Derivative of e to the x is e to the x. 3 to the x sine x. Now we do f, which is e to the x. Now we do the derivative of 3 to the x. Derivative of 3 to the x is 3 to the x ln 3, and h is sine x. Now we do f times g, so that's e to the x, 3 to the x, and the derivative of sine x is cos x. And if you want to take out e to the x, 3 to the x is here each time. So if you wish, but you don't have to, but just to do a bit of factoring. So e to the x, 3 to the x, so it's a sine in the first one. And we take it out of here, we get ln 3 sine x. And we take it out of here, we get cos x. So that's if you wish to factor. So if you have the 3 of these done correctly, you get 3 marks, 1 for each. So that's the pattern I remembered. F, G, and H 3 times. We do F, derivative of F, derivative of G, derivative of H. Now number 7, show that d dx of this division here is equal to this expression. So before we start, d dx, now we don't know about the quotient rule yet, so we have to go y cubed x to the negative 6. Now that makes it a product rule. So that makes it f, and that makes it a g. So the derivative here, derivative of f, so we have y cubed derivative x to the negative 6, and we have plus y cubed, and we have to do x to the negative 6 derivative. So derivative of f times g, and f times the derivative of g, with the plus in the middle. So when we do the derivative of y in terms of x, we do the derivative as it is 3y squared y prime x to the negative 6. Y cubed, do the derivative here. The negative 6 goes in front, and this negative 6 minus 1 is negative 7. Now we want to get it to look like this, so that means there's no negatives here. So we get 3y squared y prime over x to the 6th. And we have y negative 6 y cubed, and x to the negative 7 goes down the bottom. And you can see x to the negative 7 is a common denominator. So the LCD here is x to the 7. So we multiply this one by x, and we multiply this one by x. That gives us 3xy squared y prime all over x to the 7. Subtract 6y cubed over x to the 7. This is already the common denominator, so we only got to multiply this numerator and denominator by x. So that gives us 3xy squared y prime minus 6y cubed. Same denominator. So there it is there. That's the proof. And again, if you changed it, you had to change it to this step first. If you did your derivative, right here, you get a mark. If you move the negative down the bottom, you get a mark. If you simplify it to here, you get a mark. And you get 4 marks altogether. Now, you didn't have to give a mark here. You could have given the mark right down at the end instead of here. But because we don't have a quotient rule, you got to change this first. So 4 marks altogether, add up a page, you got 12. And hopefully you'll understand about the product rule, and you know your different derivatives of your different functions. So that brings us to the end. And again, if you like my video, click on the like button, click on the subscribe button, visit my math website www.mathfullyexplained.com to find more information about me, my videos, the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye bye.